Okay. Now, knowing that we have both CI for mean, such as this one, and CI for population proportion, we know that we can find the number of samples if it is involving sample mean and proportion, sample proportion. Now, example 3.4 on page 83. So the given information other than alpha is 0.01. The acceptable error, okay, acceptable error. I hope everyone remain in the class because I need to introduce you to the hypothesis testing, which will be very important for you. Okay, so acceptable error. So this is what is called by your E, and it is given by 2. Okay, and what else given? From the previous study, it is known that the standard deviation, so that will be a hint for what we call known sigma. So in this case, sigma is equal to 4.333. Okay, by using all this information, how can we find n sample size? Okay, so here check for the alpha first. We know that if we are talking about CI, we have the lower limit and the upper limit. So we are talking about alpha over 2, which is 0.01 divided by 2. That will be 0.005. So Z 0.005 is given by 2.5758. Okay, should be plus minus, but since we are talking about the margin of error, so take just the positive value. Okay, now we know that E is given by the whole thing here. So E will be Z alpha over 2 multiplied with sigma divided by square root of n. Now we know that we need to find what is n. Okay, so to make it easy, we bring this n here and we bring E to here. So this will be square root of n equal to Z alpha over 2 multiplied with sigma over E. Since we have square root of here, so in order to find n only, so what we do, we square both sides. Okay, so that we have n equal to Z alpha over 2 sigma over E, the whole thing here. So put everything together, so Z alpha over 2 is 2.5758 multiplied with 0.01. Sorry, sigma is not 0.01. Your sigma is 4.33 divided by the margin of error 2. The whole thing squared. Okay, so n will be obtained as 31.1. And in this case, we are going to approximate, it becomes 32. So the sample size needed for this particular investigation will be 32 measurement of the river depth in terms of meters. Okay, so you need to find what we call 32 rivers, and you are going to measure the depth. Okay, now that will be example 3.4. What if it involves the proportion? Okay, now before that, if we are talking about 99%, so your alpha over 2 is given by 0.005, and your Z alpha is alpha over 2 is 2.5758. Now class, if you reduce the confidence level, means that you reduce it to 95%. Okay, what happened? Your alpha over 2, see my handwriting also, so alpha over 2 is 0.05 divided by 2. That will be Z 0.005. 0.025. Right. This will be given by what? Can you look for Z alpha 0.025? What is the value for that? Zero point zero two five. 0.025, 1.96, right? You will get 1.96. Now, this kind of question is what we like most when we do when we give assessments to students, because it will not require a lot of calculation, but you need to understand the concept of how the confidence level affects your calculation. For example, if 99% CI, you will get your critical value 2.5758 and you will get N 32. But if you reduce the confidence level, you are talking about 95%, so you will get Z alpha 1.96. So should your N here greater than 32 or N less than 32 class? Right. Should be less than or greater than? Class? Should be greater than or less than? Class? Are you all with me?
Less than.
It would be greater than or less than? Okay, less than. Thank you. I cannot hear you clearly. So it will be less than because we have smaller what we call critical value. So this kind of what we call understanding will be asked to you. Okay, so you can imagine what kind of question will be asked. So apart from calculation, please make sure you do understand the concept of the things that you calculate. Now, for example, 3.5, I think you can look at it on your own. For example, 3.5. Let us look at one exercise in your textbook on page 84. Okay, exercise 3.3, page 84. Now, let's say I choose question number 1. The diameter of 2 years harum manis tree is normally distributed with standard deviation of 8 cm. Now, you are talking about 2 years harum manis is normally distributed with standard deviation of 8. Okay, now sigma is 8 cm. How many trees should be sampled if you want to estimate the mean diameter of all harum manis trees within 1.5? So within 1.5, so that will be your E 1.5. Okay, and with 95% confidence level. 95% confidence level. So in this case, Z alpha over 2 will be Z 0.05 divided by 2. Z 0.025 is 1.96. Okay, one that we checked just now. Okay, now we begin with the mean. Let's say we do the proportion. Never mind lah, we do the exercise for proportion. Okay. Do you want me to proceed with question 1 or question 2 class? Because I didn't show the proportion example.
Question 2.
Let's say we do question 2. Huh? Okay, question 2. Okay. Question 2, a lecturer wishes to estimate the percentage of students who pass mathematics subject in semester 2. He wants to be 95% confident, so 95% confident, to be accurate within 3%. So within 3%, that will be your E, 3%, and this will be 0.03. The true proportion. How large a sample size would be necessary if the sample proportion is who pass is P hat equal to 0.5. Now, in this case, you have been given the proportion directly. Somehow, maybe you need to find the proportion on your own. Okay, so in this case, P hat is given, which is 0.5. So for 95%, okay, so 5% confidence level. So your alpha is 5%. So your Z 0.05 divided by 2 would be Z 0.025. That is 1.96. Okay, so from here, we know that E would be Z alpha over 2. Okay, multiply with P hat 1 minus P hat divided by N. Okay, we need to find N. So since I have the square root here, to simplify everything, square both sides. Okay, square both sides. When we square, we will have E squared equal to Z alpha over 2 squared. And this one, the square root will clear. Okay, so you will have P hat 1 minus P hat divided by N. Yeah. So bring your N to this one and E to this one. So you will have N equal to Z alpha over 2 squared. And then you will have P hat 1 minus P hat divided by E squared. Okay. So that would be how you can find your N. To put everything together, the alpha over 2 squared, it will be 1.96 squared. And you will have 0.5 multiplied with 0.5 divided by E squared to 0.03 squared. Okay, to calculate for this, we'll get what? 1.96 squared multiply with 0.5 multiplied with 0.5
0.11
divided by 0.03 is it 1067.1? 1067. So in this case, I'm not sure why the answer is not taking the approximation 1067. So N would be 1067, maybe because less than 0.5. Okay. So this will be the number of samples required for your experiment or investigation. Okay, that's all for finding the sample size of your what we call it involving the population mean as well as the population proportion. Okay. Hypothesis testing. Are you all okay, class? If I proceed with hypothesis testing, because my class with RK24, okay, thank you. Okay, one hypothesis exercise 1. Sorry, 3.3. Number 1. Okay. Now, what is the question? The diameter of 2-year-old harum manis trees is normally distributed with standard deviation of 8 cm. Okay, class. So please be more meticulous when you read through your question. Now, the given standard deviation is 8 cm. So in this case, what is your 8 cm? 8 cm refers to your sigma. Okay, so in this case, it is 8 cm. How many trees should be sampled if we want to estimate the mean diameter of all harum manis trees is within 1.5? So the margin of error is within 1.5 pm. Okay, and with 95% confidence level, and your alpha is 0.5%. So 0.05. Okay, now we know that this will be that 0.05 divided by 2, it will be that 0.025, and then you will get 1.96. Okay, so this is the sigma and this is the error. So put together, so if I just take this one, okay, so putting together everything, so n would be 1.96, okay, squared, multiply with the sigma, that would be 8, divided by margin of error 1.5, whereby this also needs to be set. Okay, so n would be 109.27. So I keep few what we call percent, yeah. So more or less, you need for this particular investigation, you will need 110 trees with 95% confidence level. Okay, so the sample needed for you is 110 trees. So you need to find harum manis trees for 110. Okay, so that would be for finding the sample size if it involves the population mean. Any questions so far, class? Okay, so we finished with the finding the sample size. Then I think if you